Yes, welcome to this tutorial. We want to look at a simple difference between tapping and threading. We'll be using M10 by 1.5. So let me change these holes for the purpose of us learning how do we do tapping, how do we do thread milling. So I want to use M10 by 1.5, so which means I will need to make my hole to be, I'll use 10 minus 1.5. So this is 10 major diameter, 10 minus the pitch, so I'll get the internal diameter. So the internal diameter is ID will be 8.5. So I need to make a hole of 8.5, then I do tapping and then thread milling. For the upper one, I want to use it for tapping. For the lower one, I want to demonstrate it for thread milling. Okay, so I've done my preparation, and then I want to do a simple stock. I want to define my stock. This is for a company, so I want to define my stock. Let me sketch a simple stock here. I want to demonstrate how I'm going to use what we call 3D. This is not at the center. I want to use a 3D stock, 3D model as part of my stock. 3D model as part of my stock. So this is the center now. So I can use this one as my part of my stock. So I have to check that my stock have a stock of 8 to 8, for example. So you have to check your stock, how much stock you have. So I'm assuming this is my stock. Then I want to show you simplest way of doing it. I want to extrude this in Control 7, Control 1. So on the upper one, I want to use for facing 2mm. Then ensure that you uncheck merge. Then for the lower one, I want to use you can say maybe up to surface. For example, let me use 12 for the purpose. This 13, I can use 13, yeah. So that it goes somehow deeper. Then okay, ensure that you uncheck merge results. Okay. Then so if you want to see your model, so we have put our stock. So I want to put the stock here. I can put this. I can name this as my stock. Then this is engraving. So let me say this will be engraving. We have engraving there. Then for this stock to be seen, for the target to be seen, I can click on this stock. Then I right click, say change transparency, so that I can able to see my target. So that is the target. I can put all this, or let me first of all remove this mark position, because I had already done some setting on this so that I don't use the original mark that was there. I can save this. Then I can put this one, all this up to here. Let me put up to here. I can put them under one folder, So I can say this is my target. So I have the target, then I have the stock. Okay, so what do we do? I want to remove these sketches here, so they don't need them for now. Remove them. So I have the target, then I have the stock. So what do we do? So next is ensure that you activate your SolidCAM. So I'm using SolidCAM 2024 here. So ensure that you have activated your SolidCAM. You can come to SolidCAM part, or you can come to tools, then you go to SolidCAM milling. So you have milling. If you're milling an STL file, you have turning, mill turn, then YIDM. So depending on which machine you have. For me, I want to do just demonstrate for the purpose of using 3D milling. If you want to use mill turn, you can use this. But for me, I want to demonstrate using milling. Then I can save because I've made some changes. Okay, this is scan. Then here we have two options. You can program SolidCAM to be either internally or externally. If it is the external file, it will compress to be PRT or PRSZ. But if it is internal, it can save inside the SolidWorks part or SolidWorks CAM. Sorry, SolidWorks assembly. So I want to use internal. Then I click OK, so that you can save my file inside the SolidWorks without having an external file as a standalone for SolidCAM. Then First procedure is definition. You have to define your coordinate system, that is part origin. For example, if you're using G54 up to G59, so you have to define your coordinate system, the part origin, that is X0, Z0, and Y0. Then you have to define your stock. Remember, you have done our stock here as a transparent part, then target. So first of all, let's start with the coordinate system. The coordinate system is very simple. What you do is, first of all, you click on this select face, then you come here, change that you want. It depends on which side you want to put. So you can put your coordinate system to at the corners or at the center. For me, I like putting at the center because that is how I can compensate my mold. Then I can put the take top center of the model box. Then click on this top face of the target. Sorry, of the stock, because we have elevated or we have increased our stock by 2 mm above the target. So if you click on it, automatically it will place the origin at the center, because already we had positioned it at the correct point. So normally, if I click Control 5, that is top plane, you're able to see that YX is on this longer side, then Y is on the shorter side. That is how the machine is defined. Machine is designed for CNC milling. The longest side is normally X-axis. The shortest side is normally Y-axis. So in case you don't want to, maybe you want to change the coordinate system, you have the origin, you have the option here to flip. You can flip all this so that you can change to where you want it to be. So for now, I want to leave it the way it is, and click OK. Once it is done, let's go to now defining our target, because we have defined our stock. That is, we have defined the stock, we have defined the coordinate system. Then now let's go and define the target. The stock now, sorry, the stock. So our coordinate system is already picked, and then it has detected that there's a target. So because I didn't merge, so it has detected the target. I'll show you the target. Let me go to stock first. So the easiest way, if you want to find a model, is just using 3D models. Very, very fast. It is good for me. I like using 3D models. So you click on 3D model, and then you pick this transparent part. So it can detect. If you click here, show, you're able to know that this is the target. The stock, the material which has already been cut, either you call it workpiece or blank material, the one which has already been cut. Then I can click OK. The next thing is, I want to show you the target. So maybe it may have merged the two of them, but you need to check. So you click on target. You can confirm that indeed whatever it is there is the target. So click also show that you know that whatever you are handling with is the correct part. So this is the correct part for the target. I think this was a signage that we can put in our company. For the purpose of, we can do an engraving for this. We can also do laser cutting, and at the same time we can do ADM. So this is a simple part I want to demonstrate. Okay, so the target is okay now. Then for other SolidWorks, I think SolidCAM below, maybe I think it's below 2021, you may not find this when you are defining your coordinate system. But for, I think SolidCAM above 2021, you may find this feature has been added. So this the addition of the SolidCAM as it advances. I think it also have SolidCAM 225. Currently I'm using 2022. So if you click on this feature recognition, it's able to recognize features just like CAMWorks does. It is able to recognize features, machinable features. So it has detected. You see, it has given me those points, all of them. Then okay. So all of this has been checked. It is checked. So it means that you have done our setup well. Also, you are allowed to change the machines here. You have the kind of machine I'm using, cement. Then the material, you can also check the material. If you're using aluminum or using whatever material you have, so you can change material from this side. That, for example, or let me use. Let me assume I'm using aluminum. This kind of aluminum. But you must know the machinable features. You can leave it the way it is. You can edit the machine database, but you can leave the way it is. Okay. So that is what we have done and our setup. So next thing is, once we finish our setup, is now doing operations. What is the sequence of operations? First thing is, normally you can do either drilling or you can do facing. But if your first surface is not good, basically you have to start with facing. So I'm assuming that the stock is not well prepared and to start using facing, or you do surface grinding before you bring to a milling machine. But if you don't have a surface grinding machine, you can do facing. So I want to start with facing operation because my main aim here was to show you how to do tapping and at the same time how to do thread milling. So I want to use facing so that I can go now to the next operation. So you can either use part model or you can use, because our stock is larger, we cannot use part model, so you'll use the stock model. So then that is the geometry. Geometry, it means where you are going to cut. Then tools, so let's click here, tools, then you go to tools, you select your tool. Because you're doing facing operation, you must also understand that every operation must go with the right tool. So double click on this face mill, then you can orient it with the right parameters if you wish. So all these are the parameters. In case you have larger one, mine I'm having 4, then how many types of the inserts are you going to use, or fluids? Then the insert here, you must know the step of the insert you're using. If you're using AP, MT, or whatever insert, so you must put the right insert for this. Also, the helical angle, so it depends because the tools may be different depending on the helical angle you are using. Most cases, this face mill, you can update the parameters here if you wish. Basically, for me, I want to put 500. I don't want to go too faster because the tool I can use 100 for that, for roughing, the finishing. This can be 800. This is 400, for example. But this is a formula for calculating, so I don't want to show you that formula for now, because that is what we train people when they come to our shop. Okay. So this is the kind of tool we have. Okay, then click OK. That is the tool we have set. So that's facing, then level. I want to put 5 so that I don't go further away. Upper level, you know, automatically it has picked the 0 point where you have put. You click on that, face like that. Then lower point, you can already, we had put an extra of 2 millimeters, so you don't want to increase any. Step down, I want to use maybe 0.5. But we can use, depending on the material, you can use 1, you can use 1 or 0.5. I want to use 0.5 so that I will show you how it will be doing for demonstrating. Then here I can also want to use contour. Then parameter tool, I want to use 70%. Yeah, 70% is okay. And then the type here, you can change here, adjacent is linear. And here, when we are doing climb milling, we are using climb milling. Then the link, I want to assume that I want to leave by default file now, but I'll show you the link when you come to our class, what it means when you're doing linking. Then let's do simulation. We see how it can do these operations. So then we go to our main agenda of doing tapping and drilling. If I'm able to do this one, you're able to see how it's doing facing. I can also increase this to show how it will be doing facing. But remember this one, I said I'm using 0.5 because of the purpose of demonstration, but you need to put the correct parameter for depth of cut. If you're able to see this, these are the toolpaths. If I click this control 1, you see the red ones, these are lines, which means the tool is approaching from this one and going all the way. So the red one is tool approach, the green one, the blue one is the tool cutting. And then how many number of parts it will go. So this is the first pass, second pass, third pass, fifth pass. If we're able to calculate, I've put 0.5, and remember you have 2 millimeters. So it is 2 divided by 0.5, you get how many passes. So first pass, second, third, fourth, fifth. So that is what you're able to do. If I do 2 of them, 1 millimeter, it go 2 times. If I do 1.5, it may go maybe 1 time plus, that's 2 times. Then you calculate the remaining. So it depends on the number of the depth amount you have put. In case you don't want to see these 2 parts inside, you just click this one, then you hide. Or you click again, it will show the 2 parts. Okay. If you expand more on this one, you're able to see the upper level and the face depth. So it gives you all this. If you go to MasterCAM, it gives you more of the features here. Okay. So let's go to our next operation is drilling. But before we do drilling, we need to do standard drill. So how do we do standard drill? So because we don't have a program for standard drill here, we use drilling. So we click on drilling, but the tool will change the tool to be standard drill. Then here, click new geometry. Where are we going to do our drilling? So click drilling, new geometry, you click those faces, for example, these faces. I'm doing this part because, but I've not done chamfering, but I'm just assuming for that case. Then these are the parts you put on the machine. So the number one is this, number two, something like that. So we have six. We have six holes, and these are the coordinate systems. These are the coordinate. This is the machine will be following this to read. That is x and y, x and y. Okay. Here you see we are using the plane x. XY, that's G17. We're using G17. That's why it's giving the earth this plane, which means it is on top. That is to the drilling. Okay. So even you see here it is 2D drilling. So you have 2D drilling and 3D drilling. Okay. So our main objective is to show you how to do 3D milling and tapping. So let's go to tool. Because we're doing center drill, we click here center, then we select the tool. And then here we pick our center drill. Because we have picked the center drill, so we took this center drill, double click on this center drill. Put the parameters here. I'm using center drill 5, so I can put here 5. Then here I can change the parameters here. Don't want to do finishing for that case. I can do 300. I can do 1000. Don't want to do it so fast. Okay. Then I click OK. That's the center drill we are using. Then levels, I want to put 5 here. Upper level, click upper level, for example. I want to assume this here, but it's good to be down because we already have done our setup, or it will just go down right to that face. I pick that face as my depth, and then here I want to put 3. That is already 5. Then that is okay. Full depth. Then here technology, I can become advanced sort. Then I want to use this type of sorting. Then drill type, I want to use G83 for the purpose of not breaking the tool. Q can use 2. This one I can use 1. So you need to understand these parameters here. What Q, J, Q, I, J, K, P, and whatever. I'll say full step for if you're using G83. So I don't want to show you that one because that is the tip for our work. Okay. They can do simulation here. So very quick. See? So that is center drilling. We have done our center drilling. The next is, instead of me creating a new program because I want to do drilling here, I do is that I click on this one, then come down where you have copy, then I click again here, then come down where you have paste, or you can use shortcuts, Control C and Control V. Then click on this one, edit, because I don't want again to repeat the same procedure, but I'll change something. So geometry is the same, where I'm going to drill. The tool, I'm going to change the tool now. Instead of using cell drill here, I'm going to pick a tool for drilling. So I want to do step drilling. First of all, I will do 5, because I want to do 8.5. I will do 4, and then I'll do 5, and then 8. So double click on this one. So the drill we are using, we can use even 6, okay? So no problem, we can use 6. Then we can check the parameters here. We can check parameters here. We don't want to do fishing. They show that we calculate the parameters. That is 6 times 6, 3. That is 4200. Sorry, what is it? 500. Okay. So, and then I can check the level. So level here, I can check the level, upper level. So I want to make sure that it goes all the way up to this phase. Then I'm assuming that the clamping is good, so I can say go -3, but it goes all the way down. Okay. Technology, I want to assume I want to change this one to be 3. This one can be 1.5. Okay. Then there's something I want to change for the tool. You have put the correct tool. But you change also the coolant, that you have put the coolant here. Tool change, I don't want to do tool change. Is the data you can change from here. The number of gears you're using, okay. Then the tool, it's okay. Level, check levels, okay. Technology, it's okay. Geometry is the way we're doing drilling. Then clear, calculate, say yes. Then do a simulation, say yes, because you have increased the depth where we want to do drilling. Okay, solid verify. In case it's like this one, you can change here this icon, click on this icon, it goes to isometric, then you do your drilling. If you're able to rotate this one like this, you're able to see it has done the drill up to down there. Okay, so that is for, we have used 6. As I said, we want to use M10 by 1.5. So next is again copy the same program, copy this second one, copy this, scroll down, copy, then right click here, go down, paste. Shortcut way of programming, paste. Then click this one, edit. Now the tool we want to put the tool to be 8.5. They will do the same here. Change the tool now to be 8.5 here. Again, take a new tool for 8.5. Double click on this drill. You can put the parameters for drill that you are using 8.5. So we need to have a whole of 8.5 for all these parameters. I want to assume these parameters. Okay. So in case you don't want this, you can come to tool here. Maybe you made an error. You change here. It's a cutting conditions. It open up cutting conditions. You uncheck this that maybe you don't want these cutting conditions. You can check that collant. Okay, the same. Keep change. Then you go to levels. Levels. For this case, we assume the same. Technology we can change because of the we have increased. I can change to before and calculate. Yes. That do a simulation. Yes. Want to see solid verify. How will it be like this? Okay, you can reduce the speed here. So that is the drilling. Okay, if you're able to rotate this one, you see it has also enlarged. So we have been doing enlarging our holes. So now we have our holes. I want to do this upper one. I want to do tapping, then thread milling. So let's go to our tapping. So for tapping, how do we do it? So let's start with tapping. For tapping here, if you look at this for SolidCAM, we don't have anywhere written tapping. But how do we do our tapping? So just take normal drill, click here, drilling. After pick drilling, let's pick the geometry. We are going to do our tapping. I want to assume these are the holes. As I said, we are using these 3 holes for tapping. For the tapping. So these are the holes we're using for tapping. I'll click on it. Again, change for the tool here. Here, the tip. Because we want to do tapping, before you go to the tool, ensure that you change here. Yes, you have these 3 of them. In case we're going to use now, sorry, for thread milling, we change this one. But for tapping, for example, if you click on this one, it will show you an error here because you have changed the program from now drilling to thread milling, but we are using 2D drilling. So it also changes here. So for the tool now, go to tool, select the tool, then we pick a tapping tool. So here we pick a tapping tool, double click on this tapping tool for tapping. Then also all the tools here, so you are using tab tool. The tab tool we are here using here, as I said, is our pitch is 1.5, so I change here to 1.5. Then what was the diameter here should be 10. The tip here, tip diameter maybe because of chamfer, if you put a chamfer of 2, that is 4. If it has a chamfer of 1.5, maybe that's 1.5 to 1.5, get 3. 10 minus 3 get 10. Sorry, get 7. But if you're using one, maybe chamfer of 2, it will be 2, that is 4, 6. So this one can be 6 because of chamfer. The remaining can be the same. Okay. The chamfer, then which you see it has already detected that there's a chamfer of 2. Then the cutting length, so you also check the cutting length. Maybe normally let me put 24. My cutting length 24, for example, or can put even the depending on the parameters. So I don't want to reset you. Check the tool that you are using, then put the right tool for the tool. Okay. Here, how many fluids I have? My tool has a number of 4 fluids. Therefore, 4 cut parameters here. Check that here and check these ones. I want to use 7, 14. I want to use 475. So you have this one. I've done my calculations. So you need to know how to do calculation for this part, fit rate and spindle speed. Okay, for tapping, depending on the tool you are using. Okay, so then I can click OK for tapping. Then level, as I said, for this one I want to put level 5. This one, the depth is auto. You see, the depth is auto, so you can put automatic. Full depth is already picked 15. here. I want to go down by 3, then technology, sorting, click here sorting. I can use this sorting, second sorting. Then here, you have for tapping, you have 2 codes. First code is G84. That is first tapping. Second tapping is doing like what you call peg tapping. So for tapping, we're going to use G84. So I don't want to use peg tapping. High chances it may break. I want to use this. And then also you don't do tapping for hard materials. So you need to understand that for hard materials, don't do tapping. You do thread milling. Okay. So we are using G54 and this is a CIMCO. Then our safety passes where you're linking, you're using clearance. If I use shortest distance, I don't want to use shortest distance, I want to use clearance level. That's why I put level here and a level clearance level, I put 5 so that it will go to 5. We're not going too far away from. Then I want here calculate. Say yes. Yes. Then we do simulation here. Say yes. Click here, solid verify. And then you can click on this, then you do maybe show colors. You can change the colors if you want, you can put those colors. You can click on this. You see, that is the tapping we have done. I'll generate a program, I'll show you the program. So next is next operation is this. I can rename this one, for example. I can rename this, let me check. I can rename this as tapping for the purpose of my header. Then this one I can rename as facing. This one I can rename as center drill, centering, or let me say put it centering. This one I can rename as drill with diameter 6. This one I can rename as drill with diameter 8.5. So that's all my header. Okay, then we put the last operation here. Again, last operations. As I said, here we have 2 options. We have drilling, where we'll change the drill to be thread milling, or you can use normal thread milling. So you have 2 options. So I want to, because when I'm demonstrating tapping, there's somewhere I change from tapping to thread milling, but I want to use thread milling. Thread milling for these holes. Where are we going to do our thread milling? We put these 3 holes, so this is where we are going to do our thread milling. Okay, so these are the coordinate systems, but it will picking us drill. The name is picking us drill, so that's okay. Then the tool here, now you see it has changed from tool. Previously when you're doing drilling, that tapping, we were using 2D drill, but if you change to thread milling, it also changes. Now you're using thread milling. Okay, the tool. So ensure that you follow this step very clearly. For the tool, you're not using tapping. We have this type of tools. We have taper, thread taper, and then you have thread milling. I want to use thread milling. So you click on this, double click on this thread milling, then you change the tool. So for you to be to understand how to do this, we can use you can use either table or user, because it is standard. The picture using standard. This is the number of fluids you want to use. If it is 4, you put 4. If it is 2, you put 2. I want to use 2 fluid. And then here, the cutting depth, how much do you want to put? If you find this one is very difficult for you to change, what you do is come here. Sorry for that. Come here. We have, this is British standard for, that is when you're using nibbles. You want to use taper thread, you can use this type of thread. You have this metric thread, we have the UN, we have the Whitworth, we have the Camex, sorry for that. Okay, you can pick metric ISO to be easier for you so that you don't calculate all these parameters. That is the easiest you can do. So this is the M is metric. Then, for example, M is metric, 1 is measure diameter. Then this is the pitch. So as I said, we are using M10 by 1.5. So it is also guiding you that if you're using M1 by 0.25, the hole should be 0.75, which means it is 1 minus 0.225. So you can make a hole of 0.7, 5. And then preparation, they saying 1, which means allowance. So let's go to M10. We have M10 by 1.5. So click on M10. So when the hole should be 8.5. That's why I made a hole of 8.5. Then that is preparation, which means it will cut up to 10. Okay. Then it will calculate the tool. You see, it calculate the tool. You can update the tool here, which means the tool should be less between 6 and 8. So if I put my tool as 6, let's see what happens. I put my tool as 6. I have a tool of 6. It gives you a question mark here. Why? The shoulder length doesn't match. So if you pick the correct parameters from the table, you don't want to change all those ones, but you can update. You can update this. You see, the shoulder length is taking this parameter and this parameter are not the same. So if you change this one also must be changed accordingly. So for now, I want to do this on default. So that is my secret. Then I will come here. I want to use this 714. This is I want to use 475. I can uncheck this. Then I click OK. Then we go to levels. I want to use 5. Upper level, I want to ensure that I'm starting from here so that I don't waste time. Then depth. So we are using definition. You see, depth definitions. Are we going to use number of thread or value? So here, thread depth, you can pick. I also want to put minus 3, sorry, minus 2. Okay. So the depth of this hole, how much is the additional depth? Maybe minus 1, for example. How much is you are doing the additional hole? Okay, then technology here. This is where you change your parameters. Rough. Using multiple thread, so I can use the first step. It is going to do for this. Is going to do 0.8. Sorry, that is 1.5. 1.5 divided by 2, so I'm going to do 0.75, which is 0.8. Okay. Next is I want to do that is 0.75 minus 0.5 get maybe 0.3. Sorry, that is half of it should be 0.35. That is 0.3 also. Okay. The finishing allowance I want to put 0.1. 0.01 for finishing allowance. Number of finished passes I can do 2 passes. Here I can check all these parameters and then advanced sorting. You can put any kind of sorting you want. Then linking, you see, and then also you have 2 kind of thread milling. You have from the bottom going up, so which means it starts from the bottom, then it goes up. Then the type of the thread also is right thread. If you have left thread, you can use left kind of thread. It has also detected. If you are using internal thread, you pick on internal. If it is external thread, you put on external. But because as is internal, we are using internal, and the major diameter is 10. The major diameter is 8.5. That's why you have done 10 minus 1.5 get 8.5. Here is the direction. Is your thread right thread or left thread? If it is left, you use left. If it is right, you use right. Which means right goes clockwise, left goes anti-clockwise. Then how are you cutting from? From the bottom or from up? If you're from the bottom, you're using climb milling. If you're using from top, you're using conventional milling. So let me use conventional milling for this case. The linkage, you come here, you can pick the linkage. For now, I want to leave default, then do calculate, say yes. What does it say? The additional value should be positive. Why? That's why here it is incremental. So I'll change it to 1. Additional value I have put. So calculate. Yes. Then do a simulation. Yes. Solid verify. Solid verify. We got this. Can do this like this. You see? So this is what it's doing for thread milling. Okay. Thread milling. So we have finished our main objective. Our main objective is to understand how to do tapping and thread milling. So I want to change this one to, I want to name this one as thread milling. Okay. So this is our operation. So the main objective is to do tapping and then thread milling. But you are using M10 by 1.5 and M10 by 1.5. What is the difference? For tapping, we are using drilling operation, but the tool we change to tapping. For thread milling, also you can use drill operation. If you come here, like you're doing drilling, here drilling. Instead of for drilling, you have two kind of operations. You can do 2D drilling where the tool will change to tap, so you do tapping. But if you are using now thread milling, you come to thread milling. Another option here, you can choose for thread milling. Also, you can come to operations and then you pick directly to go thread milling. So you have those kind of operations you can contact when you're doing this. If we do a rough simulation in SolidCAM, maybe SolidCAM simulator. That's the new addition in advanced SolidCAM. So we're able to see how can this one. You have do 3D solid simulation. We have turning simulation. Of course, we're not doing turning. So we have heavy part simulation. We have default simulation. And then we have solid verify. So let's use the default verify. You can do the speed and you click OK. That's our simulation. This is very simple, like that. Maybe I've gone faster, then we do that again. So it becomes simulator. I can reduce the speed for the purpose of seeing what is happening. Then I rhyme facing, that is facing. Even the operation is here is showing here down here facing. The color changes, it goes to centering, it goes all the way to the last operation. That is thread milling. Okay, even you see the tool the way it is. Okay, so we have done our setup. Next is program generation. Right click here, you can pick all of them, select all of them, then right click here, come to G code, generate G code. So you can put any name. Okay, let's use a name, no problem. Depending on the machine, the file name is important. Let's open the program. We see the program. I want to show you the key areas. I put some changes when you edit the program. Where do we change? Because the machine doesn't want to read these ones, I want to put semicolon at the back of it. This is for the purpose of you organizing the program. So we have tool 1, diameter 40 for facing, tool 2 for centering, tool 3, drilling UC 6, tool 4, 8.5, then 10 is tapping, the last one is the milling. So those are the tools we have. So it has put all these tools. Then we can put here semicolon. First, this is the header. As I said, when I organize a program, this is the header. It means that we are doing facing for the first operations. Then you can put here G00 and maybe Z120. If you don't want to use this one, because I know most people may jump this, but it's good to leave this because of the safety path of the tool length compensation. So that is facing. If you finish facing, we go next operation. When you see where it is green, the kind of program is G01. If you see G0 blue, it is G02 and G03, which means if they change the contour, also the program changes the color. Then G00, the red one, it means it's not cutting, it's approaching. The green one, it is using G01, linear orientation. The blue one, and it's using circular interpolation. Let's go. See, it finishes, and then here it stops. That is first operation that is facing. It stops speed on. That is this is optional stop. Then so that you can change to second tool. This is the second tool automatically, where we're doing centering. We are doing centering for this. I said we are using G83, so that's why I put this R. R is 0, so I can put R1, no problem. R1 Q like this P. So this is doing centering. If these two match, that's why you can also edit your parameters. Once it finishes, it goes to next operation. Number 3, we put this as drilling using the meter 6. Also, you can see these are retraction point 2. Sorry, 2. Then we go the next operation, drilling using 8.5. Put semicolon 8.5. It goes also here. I want to change. Don't know why it's not picking R, so R should be less than Q. Okay, we go down the next operation here. Tapping now. This is where I wanted us to show. You see this program for tapping. How many holes? We have 3 holes. The first hole is on here. That is X point, and Y point. This is the first hole, but it's on G98, G84. Then you have the R. Then there's the feed rate. You can also use Q if you want to use packing. Maybe you can also put Q, maybe Q3. You're using packing. Okay. And also P maybe P1 for the purpose of dwelling at a point where to do cleaning. Then thread milling, you see thread milling, how it is done. So this is for the thread milling operations. This is the operation for thread milling. You see, that's why I was putting those names in naming them for the purpose of aligning my program. It goes fast pass all the way down. It goes up, starts again, because we're doing conventional milling from top down, all the way. This how many passes, depending on how many you put, this is what it will be doing. Then I can put this one to be 0, because this showing that I am doing what you call the homing after it finishes. So it will do homing. If you don't want to use this one, you can just put G0, Z maybe 200, then X0, Y0. Then you uncheck this if you don't want to do homing. But I like using homing for the purpose of checking the controller. Sorry, not the controller, the part once it finishes cutting. Okay, we can also do part plot for this. I'm using CIMCO also, the advanced CIMCO. Let's also do simple simulation for this one. You see how it behaves. The toolpaths. I can go up here, click here, to start here. Yes. Let me pan this somewhere there and check pan. Yes. Just symbol demonstration. If I click here, play from the start, the first thing is facing. Let me increase the speed. Facing. So this one is also helped me to check the program where there's program error from SolidCAM now to CIMCO. It helped me to check the program error. That is facing. When it's doing facing, also the program is running. This is the way your machine will be behaving when it's running. When it's running, it's behaving like this. So it scans the program. It goes through all the program to check in case there is an error. So drilling, it has finished. Yes. So if I check the program is okay. I put so fast, that's why you have not seen the other operation, because I have put so fast. So don't worry. So the program is okay for this case. So what we do is this one, you go to your editor, file, save as. Depending on your machine, you need to save the program depending on the extension. So you have .mc extension, you have .h.hnc file, that is Heidemann.okma. You're using means, SSP and SUP. You're using that is Okma milling, Okma turning. You're using Siemens for you use this type of program. So it is .mpf. So you're using mpf. So you click here, save program. So this is what we have done for the purpose of learning how to be able to do tapping and thread milling. Thank you for listening. Have a lovely day.